Good afternoon, everyone. I am Mohammad Avesh, working as a research scholar in Motilal Nehru National Institute of Technology, Allahabad. Today, I'm here to have a discussion on the important aspects of vehicle suspension system, and we will share a case study with you all for better learning. So I would like to share my slide. These are the contents which will be covered for 50 minutes presentation, but I will do this presentation in two parts. First section, I will cover introduction, objective, motivation, and literature review and methodology. And the second part, I will cover the system modeling and control, simulation, result analysis, conclusion, and I will show some publications from this work. There are total 105 slides, and presentation is divided into 10 sections. So first is the background or the introduction of a suspension system. Actually, suspension system is have been used in the automotive from the beginning of 18th century. Initially, it was used in 16th century in the bulk carts or the carts driven by the horse. And after 2 centuries, then we have come to the automotives, and the suspension system have been used as the crucial part. So first, before proceeding, we should know what is the importance of suspension system, and it is very genuine question: why and what and why. What is the suspension system and why we are using the suspension system? Suspension system basically a term given to the system of spring and dampers which is inserted vertically between the vehicle body and its wheels. And why it is used? Basically, the objective of using suspension system is to isolate the vehicle body from the road irregularities in order to maximize the passenger comfort or retain the continuous road wheel contact in order to provide the road holding or better ride comfort to the occupants or passengers. From last 3 to 4 centuries, we are using suspension system, but what is the new trends? What is the trends of 21st century? So an ordinary suspension system has a spring and dampers, or we can say the like a rigid design of suspension system. But now we are trying to reduce this rigidity and making the system flexible. Flexible means flexible as per the working atmosphere or working conditions. And so we are going to replace the rigid conventional part by mechatronics and intelligent suspension intelligent systems. As the IT and computer technology are being emerged, so we have got some new technologies to make our mechanical hardware and transform the mechanical hardware to the control. So there are some new techniques: the adaptive control, neural network control, fuzzy logic control can be implemented in the suspension system to make it more effective against the jerks and the vibration of the vehicle. So these are the main or key factors of this case study, the quick response against the jerk. This is very important for a suspension system. The intelligence, consistency in the performance under uncertainties. This is also very important part, that if our design is not consistent as per the performance is not consistent when the operating conditions change, then it will be harmful to the passengers or occupants of the vehicle itself. So we have to make a design that can change its behavior, its property, its characteristics as per the working conditions. Less the energy requirement. This is also very important. And how we will evaluate the performance. There are two factors which can decide the performance of a suspension system, like ride comfort and road holding and stability. These are the practical problems which we have been observed in our daily life, such like when the unloaded vehicle or unloaded heavy duty vehicle run on the road, that it shows a jumping behavior that is very discomfortable, or we can say the very create the chaos in the vehicle body. So we have to reduce this. And when we see the light passenger car or light passenger vehicle with having the overload, or we can say the payload is increased or the number of passengers increased, then it shows the failure of suspension system, and sometimes it touch the limits. Next is you can see in the figure number 4, the turning of the vehicle. When vehicle take a shaft at high speed, then it show the failure of one side suspension system due to the transfer of load. This the Raja Ramani have very well calculated this phenomena, how to dynamic load transfer when the vehicle take turn or braking or cornering. And next is the different type of road profile may also affect the performance of suspension system, as we can see in the figure number 3. So by considering all these problems, we are going to modify the design of a suspension system, and how we can modify it. So first we should know the main problem, how we can modify, what is the design modification requirement. Actually, there are two types of suspensions. Soft suspension that is used in the luxurious vehicles, and the hard suspension is used in the heavy duty vehicles or good carriers. In soft suspension system can provide the better level of ride comfort and reduce the vibration at a extreme extent, but at hard, but it is failed to have the overload. But at the same time, when we show the hard suspension, it can take the maximum load of the we can use it for the good carrying the goods and passengers. But when vehicle unload, then it show the jumping behavior, vibration, show the extreme level of vibration due to the stiffness. So we should find a trade-off between those two parameters. But at the same time, we know that the suspension is a hardware which cannot change its property as per the requirement. So how we can change the properties? For this, we have used some control techniques, which will be discussed in further slide. And next is what kind of problems can be come across due to the exposure to vibration. There are several kind of health issues can be faced by the human sitting inside a vehicle, like the lumbar and disorder pain, the motion sickness that is occur due to the low amplitude, but low amplitude and high frequency vibrations. Then the so many problems or health problems can occur due to the vibration. So it is very important to reduce these vibrations. Next is the objective of this study. First is the design an active suspension system. This is the Newton active suspension system. We are replacing the passive parts by some mechatronics or intelligence part to make the system active control. Next is the consistent performance in unidle situations. Implementation of PID and fuzzy logic controller. Performance assessment at different scales. What maybe the scope of this work is, basically we have learned so many, we can learn so many things from this case study. Like first is the review of technical specification and design parameter of a suspension system. And it also enlightened the recent development in suspension system technologies. The quantitative assessment of the field data of the survey and published report on car market also been provided in this literature survey. The quantification and measurement of dynamic performance of a car, it is very important because there are some subjective parameters also over here. So we have to find some scales to quantify the performance of a suspension system. Next is the learning of linear and non-linear modeling of dynamic system. Vehicle is a same non-linear structure. So we have to model is a by considering the non-linear approaches. Next is the road profile modeling for development of disturbance model. We also saw the some replication of road through some dynamic models, equations, or expressions. Next is the fabrication of test setup or test rig to verify the results or validate the outcomes. Next is the active suspension system design using fuzzy logic control. This is the main approach which have been used in this research. Next and last is the vehicle performance comparison at several parameters in time domain. We can also compare it with frequency domain, but now we are using the time domain analysis. First, how we have conducted the literature survey. The literature survey of this study have been conducted at very broad level, and which have been categorized in two parts. First is the broad study, second is the minor or focus study. In broad study, we have to find why the suspension system is so important for a vehicle, and in the focus study, we have find the parameters which can improve the suspension system performance. This is a very huge literature survey. I don't think so to discuss it in detail. There are some Indian car market, Indian passenger car market, different segments of the cars. This is very important. There are two parameters, safety and comfort, out of 7 is very, very effective or influencing to a new car buyer. This the percent influence of these two factors approx 30% or to a car buyer. So we are going to consider these two factors to improve the or modify the suspension system design. This is the part B, in which we have discussed different development stages, different modification and design, different techniques to improve the performance of suspension system. And ultimately, we have found some performance measurement scales, different criteria like spelling guide index, standard method used in ISO. So we can say different range and different level of comfort, which can be calculated on the basis of, we can be measured on the basis of 3-dimensional vibration, and for which we can calculate the root mean square values to decide the performance. So several things which have been found in the literature, like we have briefly reviewed the recent development of suspension system technologies, which comprise the hardware modification, control techniques, and energy saving technologies. The conflicting requirement of road vehicle suspension system make it more complex study topic. So that modeling methods and parameter selection criteria have been discussed in detail. The next is varieties of performance parameters have been pursued in the literature. I already shown in the last slide, like Sperling index, ISO index, and we can also develop some indexing on the basis of some parameters. Next is the study organized and comparatively discuss the research method and standard referred by the numerous researchers. That would be advantageous for the academic researcher, industry persons, and the manufacturing, automotive manufacturing industries. Comfort and safety measures, road profile, and effective design parameter are obtained in the study as the key points in the suspension system performance investigation. Road profile significance has been observed because enormous vibration and disturbance transferred from road via fields. We have 5 different modeling methods. There are no universal standard to set the simulation parameters. We know it very well, so that the effort are made for better simulation, better simulations. And next is the review, provide basic understanding of parameter selection for a computer simulation that is tactful work and may affect simulation results. So this is the literature gap we have found, and ultimately I can say that we have found that a suspension system with classical methods can't be combat with the high level vibration or it is not able to provide the full comfort to the passengers. So we are going to improve the level of comfort and the ride stability or driving stability of the vehicle by implementing some control techniques, which in control techniques the system take some external source of energy. This is the methodology which is used in this work. First is the mathematics. First is the survey or the motivation. We have studied different car segments in India, factor influence to the buyer, small segments of cars over SUVs. Then we have been discuss the suspension system modeling. There are 3 different type of modeling: quarter car modeling, half vehicle modeling, full car modeling. Then we will come to the road profile modeling for providing the replication of actual road. Then the test of fabrication to validate the result, and ultimately to test the control performance by using the simulation result in time domain. First thing is the system modeling. This is the last part, last topic of this first part of this presentation. System design, road profile, and control system modeling. These are some important parameters which will be used in system modeling. With the modeling basically to get a mathematical expression of physical system. So this is the half car suspension system line diagram, in which there are 2 main parts: the spring mass and unspring mass. The spring mass, which is supported by the suspension system, and unspring mass is the below the suspension system. So this is the front end, and this is the front side view, and this is the left side view. The tire is also modeled as the spring and damper because it shows the stiffness and damping property. This is the the center part is the suspension system, and the topmost part is the vehicle body or the passenger cabin. So these are the different motions. We are considering the 7 degree of freedom system, and it is so the different motions which bounce, pitch, and roll. This is the spring mass motion ZS in vertical, or this is the vertical dynamics, and spring mass front left and spring mass front right, the 4 corners of the vehicle. It will also show the some vertical displacement or vertical movements. So this is the basically the linear approach. I will not go in detail. I will just brief. In linear approach, we are not using the non-linearity, or we are not considering the non-linearity of the suspension elements. So we simply model the non-linear vehicle suspension system through these equations. And in non-linear approach, this is very important. We are considering the non-linear behavior of the suspension part, and spring and damper are the most linear, non-linear elements of a suspension system. And we have studied these non-linear behavior by using some empirical formulas and some experimental characteristic fittings or curve fittings, and these are the non-linear equation. This is the you can see the difference between linear and non-linear behavior of a spring and damper. So next is the actuator model. Basically, in active suspension system, we are providing an actuator. We are inserting an actuator with parallel with a spring and damper to provide an external force or the compensating force to minimize the vertical vibrations. So this is the actuator model. And then controller model. The controller is, this is the basically PID controller, which is used to regulate which is used to control the hydraulic actuator movement in response to the vehicle body and road profile. And this is overall, this is next is the fuzzy logic controller, and there are different parameters of fuzzy logic control. And next is the fabrication. So I will continue this case study and this discussion in next presentation, the part 2 presentation next time. So, and in which we will show how we can fabricate the suspension system, how we can model the suspension system, which are the important parameters, how we can simulate on different parameters. So these are will be discussed in next slide next time. So thank you all for listening. And I will share my next video very soon. Thank you so much.